We have a couple sections left in Chapter 6, but we're almost done with it. Now we're going to move on to something called imaginary numbers, which is kind of different from what we've been doing. We're leaving the rest of that stuff behind. We'll kind of circle back around in a little bit. So for this particular lesson, we're going to look at simplifying square roots whenever we have negative numbers. But first, we're going to talk about a specific property that will allow us to then go into the square roots of the negative numbers. So as an example, we'll kind of see how this property gets put together. For example 1, simplify the following square roots by following the directions below here. So we have part A, multiply the square root first. So we're going to multiply these together. And then we're going to take the square root. So it just kind of tells us the order of how we're going to do this. We're going to multiply these two numbers together and get 100. Then if we take the square root of that, we get 10. Simple enough, and that's your answer. Part B. Now we're just going to look a little different here. We're going to take the square root of the two numbers we have, and then we're going to multiply our answer. So we're kind of doing it a little backwards. We have two square roots here. We're going to do the square root of 4, which is 2, and then we're going to multiply that by the square root of 25, which is 5. So our answer, 2 times 5, is 10. So what can we conclude here? We know that we get the same answer regardless. We're using 4 and 25. So what's the conclusion? Therefore, what equals what? Now, I don't want to say 10 equals 10. No. We're not doing that. We want to look back at what we originally started with. If we have this square root of 4 times 25 inside the square root, and then if we have them separated with two square roots, we end up getting the same thing. And so that's the kind of the property we're going to look at to start with, is that if you take the square root of 4 times 25, and if you then kind of break them apart into their own individual things, square root of 4 times the square root of 25, they are the same exact thing. So what's the property here? Well, we can do, for all numbers a and b, where a or b is positive, if we have the square root of a times b, what can we do then? Just like we had over here, we can break it apart into the square root of a times the square root of b. Now you can only do that if you have multiplication between these two things. Addition does not work that way, neither does subtraction. So this is the property we're looking at. If we have two things being multiplied together, we're allowed to separate into two square roots. So we'll be talking about this in a little bit, and we'll get back to it. So let's talk about this thing here. What happens when you square root a negative number? So simplify the following in a calculator. So if you were to do this in a calculator, or you could probably maybe do it in your phone calculator. I don't know if that will come up the same way, but you probably could. I'll check it out myself. Yeah, okay. So it works. If you do this in your phone, or if you actually use one of the calculators at school, you'll find that if you try this, you get an error of some kind. Now, when I do it in my phone, it says can't show undefined result. If you do it in the calculators at school, it says error. Error. And then it will usually give you kind of some kind of message saying like it's a non-real answer or whatever. So the question is, why does this happen? What is the calculator trying to do, whether it's on your phone or at school? What is it trying to do that it just can't do it? Why is this such a problem? Well, if you think about what the square root is and what it's trying to do, the calculator is trying to find some number that when you square it, you get -9. That's what it's trying to do. -9. The problem is there's no solution for that, right? So if you think of what square rooting means, it means the same number times itself has to give you -9, right? So some number times the same number equals -9. Now, a lot of times people think, oh, well, can't you just use, say, -3 times 3? Would that work? I mean, it gives you -9, but the problem is the property of square root is saying that these two numbers have to be exactly the same, and they're not. And -3 and +3 are not exactly the same. So why does this happen? The calculator can't find a same number times itself to give a negative answer. So you can't multiply I'll say same number to get a negative answer, right? To get a negative. It's not possible. You're not able to multiply the same number by itself to get a negative number. So that's why it has such an issue and it spits out an error. However, there is a way around this, and somebody created a way around this. So when this happens and you square root a negative number, we call that an imaginary number, which might seem kind of ridiculous, but it's actually pretty useful in solving some problems. And you'll see whenever we actually do it. So what they did is they said, okay, well, maybe we can combine, this property back here that we learned with defining what an imaginary number is. So what is an imaginary number? They call it I. Just the letter I for imaginary number. So I is defined as it's equal to the square root specifically of -1. So that means that these two are the exact same thing, and we can write them either way using I or the square root of -1. And I'm going to use this fact and this property to actually do some of these questions, these problems with negative square roots in there, and actually be able to do it by hand, even though the calculator can't do it. So this is pretty important, pretty big fact to remember. So let's try it. For example 3, use the property of square roots and imaginary numbers to simplify the following. So I'm going to use the property of the fact that we know that I is equal to the square root of -1, and I'm also going to use the property back here, this one right here. It's called the square root property. So watch how I'm going to start with this one here, and then I'll use the new one here. All right, so what I'm going to do is I'm going to change the square root of -9 into the square root of two numbers that multiply together to give you -9. And I'm going to do it very strategically. If I separate -9 into -1 times +9, notice that is still -9. I've not changed anything. I'm just separating it into two things that are being multiplied together, right? And if I have multiplication between two things, I can go back here. If I have multiplication between two things, two numbers, I can split it apart, and I'll do that. Let's split this into a square root of -1 times the square root of 9. And now I'm going to apply what's up here. If I see the square root of -1, I can rewrite that as I. So if I were to, say, highlight this, this is the same thing as this, which leads to I. So I'm going to replace it with the letter I. So this means it's I times the square root of 9, and we can do the square root of 9. That is 3. So as an answer, we would say this is I times 3, or you can write it as 3I. And that's your answer. All right, I'm going to do it again, now with a different number. I don't know if you noticed, but I'm using some nice perfect squares for us. So I'll follow the same steps here. I'm going to do it one more time, and then we're going to go down here and kind of get a shortcut out of it. So the square root of -49 can be written as square root of -1 times the square root of 49. It's not liking my 9s. Yeah. And then I'm going to separate it again. So square root of -1 times the square root of 49. The square root of -1 is just I. So we get I times the square root of 49 is 7. So our answer is 7I. Now, realistically, I don't want to do this every single time. I want you to understand where it comes from, the pattern, but I would really like to just look at this and somehow just get this answer. Same thing over here. Look at square root of -9 and be like, okay, it's just 3I. So what's the trick to it? So a negative number under the square root will turn positive. basically if you put an I on the outside of the square root. So in other words, if you had the square root, I'll go back to the square root of negative 49. This is saying you can make the square root number in here positive so long as you put an I outside. So I could say this is the same thing as I times the square root of 49, and then just do the square root of 49, right? Because now we don't have any issues, it's positive. So that's where we also get 7i again. So it's the same thing. So you can kind of think in your mind, well, this negative just means you're going to get an I, and then you just square root whatever 49 is. So you don't have to go through all these steps every single time. Oops. So let's talk about that property and just put it on here. So if you have the square root of negative k, they just use k this time, some number, what you can do is you can technically write it as an I and then just do the square root of k as if it were positive. And like you don't really have to know this property like as writing it down. We're just going to try to practice going from the original to the final answer. All right, so anytime you square root both sides of an equation, there are always two answers. So we're going to start solving these problems, but some of these will include some I answers. But just remember, when we solved these earlier in the chapter, it's been a while, when you square root both sides of an equation, there's always going to be two different answers. So let's look at example 4 here. Solve the following. X squared equals negative 4. If you were to get rid of this x, the squared part, and just get x, you'd have to square root both sides of the equation. And if you remember, that gives you two different answers. So one way we used to do is we used to make it two different answers like this. We'd say x equals something or x equals something else. So if you remember how to do this just from previous problem that we did, negative 4 would be the same thing as saying take an I out and square root 4. So one answer would be 2i, or remember you can also get the negative answer of that, negative 2i. And if you don't like that, you could write this as x equals positive or negative 2i. Both of those things are the same though. All right, example 2, square root both sides. So this one we have a positive 9. So when we get our two answers, like we have a plus minus, we know it's going to happen, you end up getting plus or minus just 3. This one does not have the I because the 9 was not negative. And the last one, if we square root both sides, we get x equals square root of 25 is 5. The negative part gives you the I, and we have plus minus. There's your two answers. Okay, there's a little bit of huddle to do. It's very similar to the problems we just did. You can finish those up. Couple more things to go over. So quickly, I think the next section will be pretty quick and fast. So example 5, just like variables, you can add, subtract, multiply, divide these imaginary numbers. So just treat them as if they were just variables, like any other letter, like x. It's very simple. If you have I plus I, that is 2i, just as if you had x plus x is 2x. 2, 3i minus 2i, that is 1i, or I. Either one's fine. For some reason I'm not putting my dots above it. I'm going to save 3 for a little bit later. 4, I times I. Well, that's like adding exponents at that point, so you would do I squared. 5. If we multiply these together, we have to do 3 times 4 first, and we get 12. I times I, which we already said in the previous problem, I squared. So that's 12i squared. Let's do some division. 10i over 5i. Well, let's just divide the two numbers first. 10 over 5, that's the same thing as saying 2 over 1, right? But then if you have an I on top and I on the bottom, and we have multiplication here, we can cross those out. So this answer would just be 2 over 1 or 2. And then number 7, same thing. 100 divided by 50. This would also give you 2 over 1. And then if you do I squared over I, that's like doing the subtraction. 2 minus 1, so there'd be 1 left. So we have 2, divide them, subtract them, you get 1i left. There we go. And then number 3, which is kind of like a little tricky and looks disgusting, but it's not really not that bad. the square root of negative 16, just doing the regular square root here, we're going to get square root of 16 is 4. Since it's negative, we got to put an I. Bring down the minus sign. The square root of negative 64, well, just do 64 and you get 8. The negative sign means an I. So now they're actually considered like terms. They both have i's in them. 4i minus 8i would be negative 4i as an answer. Again, just treat it like a variable. So then there's some team huddle. But we're actually almost done. I just have to go over this last part here, which might take a little bit, and we have to fill in some of the blanks. That should be everything. All right, last part here. So we're going to look at the 4 different I values that we need to know. We have I to the first, and what we're really going to do is I'm going to show you how to get these answers, and we're not going to use square roots as our answers for the most part. We're just going to keep them without the square roots as best as possible. So we know I to the first is square root of negative 1. Don't write this though. I'm just going to keep it as I. We know that's true. That's true. I'm going to use that fact over here somewhere else, but so just know that we have this. But if you have I to the first, that's simplified in I terms is just I. Pretty simple there, just I. Now I squared is a little different. I squared, you can actually simplify this, and I'm going to show you that with this property down here. So I'll just put it underneath here. If you have I equals the square root of negative 1, which is the property we used before, and if you square both sides, so if I put a squared over here, and if I square this side, what ends up happening here is that the 2 in the square root here, like we've seen before, they kind of cancel each other out. So really, I squared, I'll put over here, I squared is equal to what's inside the square root, negative 1. So this is a pretty key one to remember. When you see I squared, you don't have square roots anymore. It just equals negative 1. Okay, so if we have I cubed, another way we can write this to figure this one out is that it's I squared times an I. So what I'm doing is I'm separating the 3 into a 2 and a 1. And you're allowed to do that because if you were to put them back together, you would get 3. We already know what I squared is. It comes from over here. We already know what I to the first is over here. So this would be the same thing as saying I squared is negative 1 times I to the first, or just I. Guess I didn't need the first. And what's negative 1 times I? Just negative I. And then the last one, which is also a pretty special one for us to remember. 2 and 4 are both ones that get used quite a lot. The last one, we could do this again. We can separate I to the fourth into I squared times I squared. And we know both of those, right? It's just negative 1 times a negative 1. And that actually turns into a positive 1. So I to the fourth gets you back to just the number 1. All right, we're going to do 2 more where we keep going. We did 1, 2, 3, 4 as exponents. We're going to repeat this and see what happens as we go to 5 and 6. This one's going to be kind of interesting. Okay, so I to the fifth. So what do I know? I know 1, 2, 3, and 4. So you can kind of separate however you want. I'm going to use this nice, easy one over here. I'm going to separate I to the fifth into I to the fourth times 1i. So you have 4 plus 1, which is 5, right? So we already know I to the fourth is 1, and we know I to the first is just I. So 1 times I is I. Interesting. So I to the fifth is the exact same answer as I to the first because of the way this simplifies. Let's try I to the sixth. I'm going to do this again. I'm going to separate into 4 and 2. So I to the sixth would be the same thing as I to the fourth times I squared. I to the fourth, we know, is 1 from over there to the right. We know I squared is negative 1, so it's 1 times negative 1, which is negative 1. That's also kind of weird because we already had that as an answer as well. I to the sixth is the same thing as I squared. I think it's messing up quite a bit here. There we go. So there's this interesting property where like this keeps repeating, like kind of like in a cycle, right? We did 1, 2, 3, 4, and then when you go to 5, it repeats the same answer as 1. When you go to 6, it repeats the same answer as I squared. You know, if we go to 7, it's the same thing as I cubed. If you go to 8, same thing as I to the fourth. If you go to 9, it goes back around. So it actually makes like this kind of circle going around from one to the other, like a big circle. And no matter how high you go, and as far as the exponents, it's always going to repeat these 4 answers over and over. So I'm going to kind of show you a trick on how to do it. And the biggest thing is that every four of these, 1, 2, 3, 4, it repeats the cycle. So what we're going to actually do is we're going to take our exponent and we're going to divide it by 4, which I think I already have on the notes here. So we're going to look at this and divide exponents by 4. And then whatever we get left will let us know what answer it is, right? It's kind of thinking about, if you divide by 4, you're thinking about like how many quarters you have left. This would be like 1 quarter, 2 quarter, 3, and 4. So for example, if you divide a number by 4 and get 0.25, that gives us our first answer, as in there's 1 left, so it's just I. This also is going to be very similar to, back here. If you divide and you get 0.5 left over, it's I squared, or -1, right? 1 quarter, 2 quarters. This would be 3 quarters, I cubed, which was -I. I have that on there. And then if you get if it goes into it evenly, there's 0.0, nothing left over. Oops, I'll go back here. That means 4 went into the number evenly. That means it's just 1. So let me show you an example of how easy this can be. So what you're going to do is, we know 7 is probably going to be what? It's right after 6, so it's going to be I to the third, or -I. What you're going to do is you're going to take 7. You can go off to the side somewhere. And we're going to divide it by 4. I'm going to use this. Divide exponent by 4. And you end up getting, I don't care what the whole number is necessarily. You end up getting 1 point, right? It's 1.75. You can use a calculator for this. I'm only interested in the remainder. So you look at the remainder here. It is 0.75. The answer is -I. That's kind of how easy it is. I don't care about the whole number necessarily. We just want the decimal. What remainder do we have? So this is kind of just a shortcut trick that I've learned to use, and that I think is super useful to do higher powers. Okay, so number 2 here, we're going to get to some bigger numbers. I to the 16th. If you go over and you take 16 divided by 4, I don't know if you know this, but 4 goes into 16 perfectly. It's 4. There is no remainder. And so which one does that match up with? This 0.0, because you can write this as 4.0. So that means the answer is 1. You would keep going through the cycle. Every 4 gives you the answer 1. So I to the 16th is 1. You could waste time doing this, right? I to the 4th, I to the 4th, I to the 4th, I to the 4th, right? 1, 2, 3, 4. That's 16 total. But all these would reduce to 1 times 1 times 1 times 1. Gives you the same answer. Now, clearly, when we get up to these high numbers, 178, I'm not going to be doing that. I'm not breaking this apart multiple times. I'm just going to use the trick. Divide by 4, see what the remainder is. Something like this up here is something you have to try to remember. Okay, 21, same thing, divide by 4. That gives you 5.25, right? 4 goes into 20 5 times, and there's a 0.25 left, so that means the answer is, look up here, I. Number 4, divide 87 by 4. That's going to be 21, right? That'd be 84.75. Don't care about the whole number that so much. Highlight this. 0.75 means -I. And the last one, 178 divided by 4. 160 would be 40. And then we'd have 74. This goes in evenly, I think. 45? No, wait. 160. Oh, it does not go in evenly, I don't think. 176. That would be 44, I think. So this would be 0.5, I think. Again, this is the first time we actually got a 0.5. And that would be this one here, -1. So now, anytime you see a higher power, ever, anything higher than, if you go back here, all these powers reduce down to these answers. So you should never have anything more than I, -1, -I, or 1. Because it's cyclic and it goes around and around. All right, you have one last thing left to do for mastery, 1 through 9, to practice those. And that will finish up 6.8 for imaginary numbers.